Hello, good afternoon. I am Jesus Chavarangel, belonging to Group 3 of the first semester of the degree in chemistry at the Autonomous University of the State of Hidalgo. Today, I come to present and expose, through the use of a graphic organizer, the subject of atomic spectrum. First of all, to understand this theme and its importance in the scientific world, we have to start by knowing its history and background. By the beginning of the 20th century, a large number of scientists dedicated to explaining the nature of atom by means of theories and models, where various characters founded their own models and atomic theories, improving them more and more over time. However, one of the most recent was Bohr's atomic model, which organizes the electrons of the atoms around their nucleus, where the energy is quantized, that is, it's organized in levels. Therefore, after the development of this model, a large number of phenomena began to be studied, where the atomic spectrum stands out. The atomic spectrum is a series of lines with certain frequencies where its electromagnetic radiation is absorbed or emitted, highlighting that each element has its own atomic spectrum. This can be observed when a sample receives thermal or electrical energy. The atomic spectrum has several important points that must be highlighted. Therefore, this graphic organizer helps to understand the topic, since it gives order to the main ideas and their details, and has ramifications that indicate a relationship. For this reason, this synoptic table is necessary. The main ideas are organized here, and its details are here. Main idea number one, emission spectrum. They are continuous or radiation spectrum. They are observed through the application of energy. Their details are continuous spectrum obtained by heating solids made from all visible wavelengths. Main idea number two, the emission spectrum of atoms in the gas phase. These don't show a continuous distribution, but do produce several lines throughout the visible spectrum. It is the fingerprint of the atoms, used to identify elements on other planets, for example. Main idea number three, line spectrum. Each atom has unique spectrum since they emit lines in very specific areas of the visible spectrum. This is the line spectrum. All atoms have their spectrum of lines, identification of unknown atoms. Main idea number four, the emission spectrum of hydrogen. It is the emission of this element that occurs when its electron passes from an orbit of higher energy to one of lower energy. This process is emission due to energy loss, excitation higher energy, return to basal state photon, radiation photon, the size of the energy difference, transition by level quantized, and specific transition are lines in the visible spectrum. Finally, main idea number five, emission and absorption spectrum. They are complementary spectrum by absorbing or emitting energy. In analysis, both are used, and each atom has unique absorption and emission frequencies. And in this summarized way, we conclude the atomic spectrum theme, which really has a primary relevance in areas such as chemistry or astronomy, and that must be analyzed in detail, since our technological tools have only used a law to determine what the emission spectrum of hydrogen occurs, but not of all elements in the periodic table. Finally, I conclude by highlighting that the importance of using this type of graphic organizers allows the study of an infinity of topics in a simple, fast, and organized way, facilitating the understanding of the subject and the acquisition of knowledge. Therefore, in professional formation, they should be used regularly for the analysis of many topics that are extensive or difficult, since they facilitate the workload and are essential in the task. That's all. Thank you so much.